almost exclusively by microbes, and only shortly before had multicellular animals appeared, almost all the modern groups of animals that we know today trace their origins to the time interval between 542 and 488 million years ago. Crabs, lobsters, insects, and horseshoe crabs? Their ancestors were there in a myriad of arthropods. Lions and tigers and bears. The first members of our phylum of chordates and vertebrates appeared during the Cambrian. Corals and jellyfish? Their ancestors were there. Worms of all kinds? Those too. The Cambrian radiation, or explosion as it has been called, has been argued about for ages, no less in recent years. More, in fact. Was the speciation rate for animals actually higher during the Cambrian than at any point since? Was the explosion an artifact of preservation? Were there more phyla, body plan groups of animals, than today? Were phyla weeded down, or did the modern phyla only appear then and continue? What does all this mean for the mechanisms of evolution? We will review some of these debates, but mostly we will concentrate on the Cambrian and the subaqueous Garden of Eden of modern animal diversity. Plenty has been written about the Cambrian previously, and much of it is deservedly about the Burgess Shale and its spectacular window to the Cambrian biota. We will see that here too. But we will also visit a lot of other places with fossil records that contribute to that picture as well, each in its own way. I hope that the picture painted here leaves you with an impression of just how ubiquitous Cambrian rocks and fossils are, and how important this period is to the history of life on Earth. I will not assume all listeners have backgrounds in geology or biology, and so Chapter 1 will introduce some aspects of the Cambrian period and biology in general, and Chapter 2 will introduce some key concepts in geology through a trip into the Grand Canyon. The rest of the book is a journey. We will travel forward in time, first through the Precambrian in Chapter 3, and then through the Cambrian itself in Chapters 4 through 8. We will visit the early Cambrian in Chapter 4, the early Middle Cambrian in Chapter 5, the Burgess Shale in Chapter 6, and the late Middle Cambrian in Chapter 7. Chapter 8 takes us through the late Cambrian. In each chapter, we will discuss some localities that exemplify each of the time stages, and the animal groups preserved at them will be presented in an order dictated in part by their abundance or preservation at each site. The journey through time dictates the order of sites we visit, and those sites dictate the order in which we discuss individual animal groups. Chapter 9 takes a look at the data from sites throughout the Cambrian, focusing in large part on the Burgess Shale, due simply to its almost unbeatable record among North American sites. Chapter 10 is a brief summary of where the animals of the Cambrian have gone in the millennia since. Scattered throughout the chapters are several boxes containing profiles of current researchers working on Cambrian issues. This is a small sampling of the modest army of people worldwide who study this time period, and it is of course not close to being wholly representative. But I hope it will give listeners a better view into how we came to know what we do about the Cambrian and its fossils. Chapter 1. Natural Mystic. An Introduction to the Cambrian. Imagine a tropical morning on the ocean. The air is comfortably warm and moist, but it is not muggy or hot. Scattered clouds are slightly pink with the last colors of dawn as the sun glares orange, low on the eastern horizon. The ocean on which you are floating is a deep blue, and the surface waves are only a few feet high. From all appearances, it could be offshore Hawaii. Pitching lightly on a large inflatable dinghy, we prepare technical diving gear and extra tanks, and notice that there is no land in sight. We're probably at least several tens of miles from the nearest land beyond the horizon to the south, but how far we can't tell. We're going deep.